So we'll get started. This week we've got shoot number 6, last one of the term. We're covering training for power. So we're going to go through what is power, the force velocity curve, strength speed versus speed strength, complex training, and the future of power training, in my opinion, where that's going, and in a lot of people's opinion. This initially was broken over 2 weeks, this tube, but with the public holiday for Labor Day, whatever it was, a couple of weeks ago, I shrunk this one into one. So we've got a bit I'm going to try to get through in the next 20 minutes or so. So what is power? Power mathematically equals force times velocity. So force being obviously how much force you can apply, and velocity being how fast you can do it. So power really is applying a lot of force as quickly as possible, and that's why there's different ends of the spectrum with speed strength and strength speed, because it's not just, I suppose, clear cut like strength, which is just applying force. I've got there, power is king. That's just my opinion. A lot of people you'll hear say that strength is king in strength conditioning. I don't agree, because I don't think that we're just training for strength. I think you need strength in order to have power, but I think 99% of the time we're training for power if you want to transfer to sport. The strongest athlete isn't necessarily the best athlete when it comes to team sport, but more often not the most powerful athlete is. So from a basketball perspective, who's a better athlete? Just from an athletic perspective, you've got Shaq there who weighed somewhere up to about 400 pounds, could probably produce more pure force than someone like LeBron James over there. But I know if I was picking an athlete to do a series of speed and vertical jump testing, which one I'd choose. So Shaq is probably stronger, but LeBron's definitely more powerful, and to me that's going to be a better athlete in a team sport environment. You look at footy, it's sprint speed. It's not just how much force you can apply. It's ability to shrug and tackle, which takes producing a lot of force quickly. So the force velocity curve, you should have seen this before. This is along the bottom. You've got velocity. Obviously, the further along that axis you go, the more velocity that's being produced. And up the side, you've got force. So obviously, the further up that axis you go, the more force is being produced. So basically, in summary, the human body can either produce a lot of force slowly, or it can produce a lot of velocity but can't produce as much force with that velocity. And that's the force velocity curve. You can see along there, you've got maximum strength up the top, you've got speed down the other end, and then we've got strength, speed, and speed strength either side of pure power in the middle. So strength speed aims to improve the upper portion of the training for strength speed, upper portion of the force velocity curve. So the ability to produce high forces as quickly as possible. Ability to produce high forces as quickly as possible. So it's not just about the velocity end of it, it's about the producing high forces, but you want to learn to apply that force quickly still, otherwise it's just pure strength. More traditional type strength training with these sorts of exercises, so your deadlifts, your squats, those sorts of exercises. But the intent to apply force quickly is key. So not just about producing the force, but trying to produce it quickly. And this is where, if we go back a lot of weeks, looking at our coaching stuff and looking at internal versus external cues, this is where I would use a lot of external cues. Throw the bar through the roof, or drive as much force into the ground as possible, not just you squeeze your glutes sort of keys. You're trying to get out as much force as possible, so therefore performance is the key characteristic here. So external cueing is going to be really effective. The guideline down the bottom there is largely just ours that we use. There's things to back this up research-wise, but if you train for strength speed, you want to be loading about 60% of your 1 RM. So if it's too heavy, you're not going to get any speed element to it, and it's just going to be pure strength. If it's too light, then you're going to be down the other end of the spectrum. So approximately 60% of your 1 RM. So it's still heavy, but you should be able to move the weight relatively quickly. Next one, we've got the speed strength. So this is, I suppose, the other side of power, where you're looking at improving the bottom portion of the force velocity curve. This, the intent to move the weight still has to be as fast as possible, but obviously the weight that you're lifting is going to be lighter here. So our guideline for this would be less than 30% of your 1 RM, and this could be, you could go into more relatively plyometrics here. So things like jump squats, if you're doing them from a loaded fashion, could come under this area here, under this sort of training here as well as your more traditional lifts. So again, you could still do a deadlift, you could still do a heavy squat or a squat, but lighter loading and rate of force development is going to be key, moving that way as quick as you can. So the goal, going back to the force velocity curve, would be to produce this. It would be nice if we could make that happen and improve all areas of the force velocity curve, but what tends to happen more in reality is that. It's hard to see, it's a little fuzzy, but basically if you train one end of the curve, you improve that end of the curve, and that's about it. It's not as simple as moving the watt across all at one time. Unless you were training all areas, you may get some transfer like that. But generally speaking, whatever area you train, whatever end of the curve you train, that's the end that's going to improve. So coming now into complex training, which you will have already seen with our inter programs. This is our inter-hour programs, intermediate power programs, are doing complex training. So this is exploiting what's called post-activation potentiation, which is essentially complex training is a heavy strength exercise superset with a speed or explosive exercise of the exact same movement pattern. So that's where you would go potentially a double leg deadlift into a squat, a double leg jump, or a lunge into a sprint, or a heavy bench press into a flat push-up. So the movement pattern you follow up with has to be exactly the same as the one you just trained. Otherwise, it's not pure complex training. It's really good for transferring strength to power, which we'll talk about a little bit later, the progression towards training for power. So it's a really nice way of converting an athlete that's already strong and making them fast. So post-activation potentiations, how complex training works. They're not 100% sure on the reasons why, but the two at the top are the ones that are supported in the research at the moment. So phosphorylation of myosin light chains, which sounds complicated. Basically the muscle or the myosin binding sites become more sensitive to calcium. Essentially the muscle is more sensitive to contraction. Increased activation of higher end motor units, so this is more the neurological end of the system, so getting increased inhibition of your antagonist, so more pure activation of the muscles that you want firing you forward and less of the ones that can stop you. Less braking force if you like, and greater activation of your type 2B motor units. So getting those big powerful muscle fibers fired up as well. Potentially a change in pronation angle, so essentially the muscle fiber orientation, they reckon that could potentially become more linear in its pull, but that's conflicting in the research and how much it actually affects force production. They don't really think that there's much there. So, it's a theory but not well supported. So the PAP window, this is the difficulty of post-activation potentiation. So if you look here, along the bottom, you've got time essentially, and up the side you've got increased output, I suppose. And so time being 0 is straight after the heavy strength lift. And you can see that to start with there's an initial little tiny increase before a drop away, and then later on down the track you see the increase in performance is more significant. So again, how the exact timings for this, again in the research conflicts because it depends on what sort of lift you've done. A lot of the research looks at a maximal voluntary isometric contraction, others are looking at back squats, others are looking at deadlifts. So, and then the follow-up exercise, what you choose to do then as well. Are you stacking isokinetic dynamometer versus doing actual plyometric squat jumps? So the timings here are conflicting, but it's generally accepted that there's this sort of path. That initially, just after the exercise, there will be an improvement in performance before a drop away due to fatigue, before you fully recover, and they reckon that second window is at about the 8 to 10 minute mark. So how easy that is to practically apply, I don't really think it is. If you're going to wait 8 to 10 minutes to do your second exercise, like we talked about the other week, you've got 3 exercises to do, that's going to, three sets to do, that's going to take you 30 to 40 minutes just for those exercises. It's not really practically applicable. So, as I said, there is no solid guidelines in the research about what exact timing that is. The ideal window I also don't think is practically applicable, so we try to exploit that first little lift there when we do it in training. So the timings we use, or the guidelines we use for training for complex training and trying to exploit the post-activation potentiation is lift approximately 80% of whatever RM you're doing. So you should have a couple of reps in the tank, essentially. So if you're doing 6s, I don't want that 6th set to be a struggle to get up, because then you've got complete fatigue of the system. And you could argue that you have to wait 8 to 10 minutes before you even have a crack at the next exercise to get any sort of response. So we try to leave a couple of reps in the tank so that when you then go to the light exercise, you've still got ATP PC stores potentially sitting there to use. 30 seconds rest before that, before the high velocity exercise. So in that time, you've got an opportunity to obviously put the weight down, take a little bit of a breath. Hopefully some of the ATP PC stores are recovering in that time before we then hit our high velocity exercise. The keys with complex training from our perspective is obviously the intent to move the weight fast in the strength exercise and then get up as high as possible in your plyometric or explosive exercise. With power, the response is pretty much entirely nervous system related, so the more drive you get from the nervous system, the more response you're going to get. The old train fast, be fast theory. And obviously the explosive exercise, as I said. So the progression towards training for power, you must have a foundation strength to start with. If you get an athlete that comes to see you and says, I want to train for power, you can't walk straight into a power program because you'll cook them. You need to give them the foundation movement patterns and foundation strength. And then after that, I would probably suggest you work on the top end of the curve first, so improve their max strength before then moving down to speed. There you go, you must have an ability to produce high force, then you can move quickly, and then you can improve their rate of force development and power. If you've got an established athlete though, someone that's already got a good training history, you go with the bucket theory. The bucket theory is basically fill the empty bucket. Imagine we've got buckets of water around here and you've got an athlete that's already really strong. Then trying to train the top end of that curve or the strength end of that curve isn't necessarily going to have much significant translation. Essentially you're filling a full bucket. Water's just going to flow over, you're not going to get significant improvements in their strength and therefore their power. But if you've got an athlete that's really strong but has an inability to generate force quickly, fill the empty bucket. So you're going to train for velocity. You're probably going to look at the speed strength end of the curve, or that's where your complex training is great. Transferring that high force production into speed of movement. But then you might have the complete opposite end of the spectrum. You might have one of those athletes that's naturally very springy and can produce force quickly. Then you need to fill the other empty bucket. You need to fill their ability to produce force. So that's, I suppose, the complexity in training for power is there is no black and white answer. There is no, this is how you train, how do you train for strength? You lift heavy stuff, basically. Produce a lot of force. How do you train for power? Well, it's not that easy. You need to find out which end of the spectrum you need to work on and try and address that. What's next in power training, in my opinion, this is the gym aware system, push bands. There's a lot of stuff coming out onto the market now where you can strap a band or a cord to a bar or a body and you can measure the velocity of the movement. So we've got the ability to measure force through either force platforms or just pure looking at weight measurements, how much weight you're lifting. But we've always struggled previously, before this technology, to know how fast an athlete is moving, and this is where they're going. I know when talking to Keegan, this is what they're using at Melbourne Football Club, is the gym aware system, and they'll have days where they're training to a speed, not to a weight, to a speed, so they have to move the bar a certain speed, and as soon as they fall below that speed, they're going to drop the weight off to make sure they're still training the speed end of the spectrum. This is the future for power training in mind, just because we've always had the ability to measure force, but with new technology, we're learning, we're getting the ability to measure speed, the velocity of movement. And to give you an idea, a push band will set you back about $250. So this technology isn't exactly expensive, it just connects to your iPhone via Bluetooth and you're off and you're going. I also think for mine, it's also got a massive opening in rehab and clinical applications. If you've got someone post-ACL coming back, you want to look at their ability to produce high velocity of force, then this is where we're heading. My last slide went blank for some reason. Essentially the keys that we went through is we built towards the filling the empty bucket theory. If you want a powerful athlete, has to be a quick athlete and has to be able to produce force. If you've got an athlete that can produce one and not the other, then fill the empty bucket. If you've got an athlete that can produce neither, then probably fill the force end of the spectrum first because it's safer after they've got their foundation stage, I suppose. The intent is always to lift as fast as you can. When you're training for power, whether you're working on the strength speed end of the spectrum, it still has to be, the intent to move fast is still key to get that nervous system response. Yeah, that's pretty much it for today. Has anyone got any questions? Thank you very much.